Hi everyone, welcome to the second half of section 4.4 in geometry. Again, we're still applying congruence postulates, which means we are doing proofs. So we are still making proofs in triangles. In today's section, we are going to focus on triangles that are drawn overlapping. So in other words, we have like 5 different triangles within this diagram right here. We are given some information. We're given angle A is congruent to angle D, and angle ABC is congruent to angle DCB, and we need to prove AC is congruent to BD, and it gets sometimes pretty confusing because everything is overlapping so much. If you can see it clearly, and some of you will totally be able to do this, then you can walk through the steps and leave it like it is. But if it's hard to see, it's worth it to take your time and redraw the diagram, separating the triangles from one another. This information has to do with triangle ABC, see this angle ABC, and triangle DCB. Do you see that? So it might be easier to separate them out and draw them as two separate triangles. All right, so here's what I mean. I've redrawn the two triangles, and it doesn't matter if my drawing is perfect. It's enough for me to see the information that I need and that I'm working with. And I'm going to go ahead and look at my given statements and mark my two triangles with the givens. For instance, angle A is congruent to angle D, so I'll mark those as congruent. In fact, I'll do that in both diagrams so you can see what that would look like. I'm also told that ABC is congruent to DCB. ABC is this angle and DCB is that angle. It's a little easier to see in these two separate diagrams, but you could also mark it here if you want and see it there. All right, that's all I'm told. I need to prove this is congruent to this. How am I going to be able to do that? I have two angles. If I have two angles, all I need is one more corresponding side. And it's really easy to see in the overlapping triangles that these two sides are shared by both triangles. BC is the same as BC. Notice I labeled, when I redrew my triangles, I labeled them so that I could see these two sides are the same. So that's the only other information I need to do angle side to prove my two triangles are congruent. So I'm going to write that down and then I'll come back and show you. Okay, here's my two columns. Remember, you always start by listing your givens. So I listed my two given angles, said they're given. There's the side. BC is congruent to BC. I listed it because I need that side. That's the reflexive property. This is why the reflexive property is so necessary. Now I can say triangle ABC is congruent to triangle DCB, angle side. But that's not what it asked us to prove, is it? It asked us to prove that segment AC is congruent to segment BD. Are they? And yes, now I can state that they are. Why? Because corresponding parts of congruent triangles are congruent. So that's how you can list it on your proof. That's the proof statement. Why CPCTC is totally acceptable as a justification. So this whole section is more about proving triangles congruent, but now we're dealing with some pretty significant overlapping problems. So we're going to work through some together through the rest of this video so you can get an idea of what it looks like before you tackle some on your own. Okay, here's an example of a type of problem that involves overlapping triangles. Here is the diagram. We are given that VW is congruent to VX and that angle WVQ is congruent to angle XVQ. What we're asked to prove is that this segment VR bisects this angle WRX. How in the world would we do that? Well, in order for that to be a bisector, we need to prove that this angle and this angle are congruent. That's our goal. And the only way we're going to be able to see those angles are congruent is if these two triangles are congruent. So can we show that those triangles are congruent? Pause the video, look at it for a minute, see if you can figure out how, and then I'll walk you through it. Okay, were you able to figure it out? If you ignore this WQ and this XQ segment, just ignore those, then you can see that I have this side of this triangle and this side's already congruent. This angle's already congruent. The next side is VR. So if I list that show VR is congruent to itself by the reflexive property, then I can say that triangle VWR is congruent to triangle VXR by side angle side. If that's true, then I can say angle WRQ is congruent to angle XRQ, or I should say V even better, XRV, because of CPCTC. And then I can use that information to show because those two angles are congruent, then VR bisects them by definition of a bisector. Those are the steps you would go through for that one. Let's look at a couple more. Here's another problem I'd like you to take a look at. Look at the information, pause the video, think it through, and see if you can figure out how you would do this. I'm given this triangle right here, and I'm told that AC is congruent to BC, and that DE and AB are parallel. What I want to prove is that triangle DCE up here at the top is an isosceles triangle. How can I go about doing that? Pause the video, think it through, see if you can figure it out. Okay, I trust that you paused the video and you've got it all figured out, but just in case, let me show you how you would go about doing this. First of all, because AC is congruent to BC, then the large triangle is isosceles, and that means angle A is congruent to angle B because of the isosceles triangle theorem. Those base angles, if the sides are congruent, the corresponding base angles are congruent. That's great. Now we are told these two segments, AB and DE, are parallel. Therefore, angle A, this angle here, and angle CDE are corresponding angles because those are two parallel lines cut by a transversal. Therefore, this angle, these two corresponding angles are congruent, and these two corresponding angles are congruent. Aha, now that I have those two angles, now I can use the converse of the isosceles triangle theorem. If the base angles are congruent, then the sides, corresponding sides opposite them are congruent, and triangle DCE has to be isosceles. Did you figure it out? Okay, this one's a little more challenging. Let's see what you can do with this one. See what I mean about overlapping triangles? We have several different triangles here in this diagram. We are told that TR is congruent to TS, and angle 1 is congruent to angle 2. Can we prove that RE is congruent to DS? This might, just as a word of advice, in this one you might want to separate these two triangles into two separate pictures in order so you can see things more clearly. Pause and try to figure out what to do, and then I'll come back. Okay, I took the time to redraw my two triangles separately, and I figured this is the triangle I want because of this angle and this triangle here. So here's triangle TDS, this one, and here's triangle TER, and I labeled my angle 1 and angle 2 like they are in the diagram, and I also labeled TR and TS, which is a lot easier to see in these two separate diagrams. Still not enough to show that the triangles are congruent, which is all I need to do to get RE and SD. That's one of the sides. If you notice though, because they're overlapping, they have something in common again. Both of them have this angle T. So since angle T is the same, it's going to be congruent. So listing out your two-column proof, list your givens, then list angle T is congruent to angle T by the reflexive property, and now you have angle, angle, side, angle, angle, side. Now you can say triangle DTE is congruent to triangle ETR in any corresponding order by angle, angle, side. And because of that, now you can say RE is congruent to SD by CPCTC. Do you see how it can get complicated, but sometimes separating them out helps you to see it a little more clearly. I could give you a few more examples, but I think that hopefully is enough to give you an idea of what you are working on and what your challenges are for this section. So go ahead and work through these problems that I've assigned you and do the best you can, and then we'll work on it in class, and I will see you guys in the next section. That's it for now.